exponential functions. And there are 3 examples. Please write all 3 examples down. Here's our first example. You want to graph this function, f of x equals 2 raised to the x power. So I've already set up the xy chart, and we're going to plug some numbers in. The first column represents your domain, your x values. Your second column represents your range, your y values. What do you get out when you plug x in? So we're going to just start with an easy number of 0. And we're going to plug it into this x piece. So we say 2 raised to the 0 power. Anything raised to the 0 power is 1. And let's just go to number 1. 2 raised to the 1 power. 2 to the 1 is 2. I'll plug in 2. 2 squared. 2 times 2 is 4. 3. 2 cubed. 2 times 2 times 2 is 8. Now let's go a couple values in the negative direction, -1 and -2. 2 to the -1 power can be rewritten as a fraction as 1 over 2 to the +1 power, or 1/2. And then 2 to the -2 power is 1 over 2 to the +2 power, which is 1/4. All right, so let's go ahead and graph those values. So you have your x-axis and your y-axis. Again, pause if you need to. The first order pair is over 0, up 1. Next order pair is over 1, up 2. Third order pair is over 2, up 4. Then over 3, up 8. And then -1, so we're going to the left on the x-axis, up 1/2. -2, up 1/4. Now we can go ahead and graph our exponential function, which is a curve. As the values increase on the x values positive, you're going to continue to increase at a rapid rate. The domain. What type of numbers can you plug in for x into the function? Well, there isn't any restriction, so we say it's all real numbers, or -infinity to +infinity. The range is a little bit harder to understand. That's the numbers you're getting out. So if we look at the y values, this is your y-axis here. Everything on these pieces that I'm highlighting here in the green, the graph doesn't exist down there. So we say y is greater than or equal to right there. So we say y is greater than 0, not equal to, excuse me. So y greater than 0. All right, next example. A little bit different because it has a negative. And with PEMDAS, you always do your exponent first, then you go back and do your multiplication, which is that -1. So let's put some numbers in again. Let's do 0, 1, 2, and then -1, -2, and see what we get out. So -3 raised to the 0. You do the 0 part first, so that becomes a 1. And then -1 will be your final answer. Now -3 to the 1 power. Again, you do this piece first. So that's 3 to the 1, which is 3. And then you multiply it to the negative, so you get -3. Now we'll plug in 2. We do this piece first, which is 9. 3 times 3 is 9. Then you have a negative out in front. Now 3 to the -1 power. Remember, those become fractions when you have negative powers. So you have 1 over 3 with a +1. So we get -1/3. And then our last one, negative, and then 3 to the -2 power becomes 1 over 3 squared, which is 1/9. So you're going to get -1/9. All right, let's go out and graph these. X-axis, y-axis. First order pair is over 0, down 1. Next one, over 1, down 3. Next one is over 2, down 9. And then -1, 1/3, -2, 1/9. All right, so here's our graph. of our exponential. As you move along the x-axis, you notice that your your y values are getting smaller. So this is what we call a decreasing function. So let's talk about the domain. The domain again is every number works. You can plug any number in for x. So that's negative infinity to positive infinity. But the range now is different than the last example. Notice all of our values are down here. So what's happening is above here is not existing in that purple graph. So it's going to be y less than 0. All the values less than 0. All right, our last example in this video is the function 3 times the quantity of 5 raised to the x power. Again, you need to do this piece first and then go back and multiply it to 3. So let's choose the same numbers as the last example, 0, 1, 2, and then negative 1, negative 2. Pause if you need to. 3, and then 5 raised to the 0. We take care of this piece first. 5 to the 0 is 1, and then 3 times 1 is 3. Next one, 3, 5 to the 1. We take care of this piece first. 5 to the 1 is 5. 3 times 5 is 15. Pretty big number now. 3 times 5 squared. 5 squared is 25. 3 times 25 is 75. And then 3, 5 to the negative 1. So you get 3 times 1 over 5, which is 3/5. Last one, 3 times 5 to the negative 2 is 3 times 1 over 5 squared, which is 3 times 1/25, or 3/25. Okay, so we have some pretty small numbers and going out to some pretty big numbers. So we're going to need to change our y values. Our x values are still fine. We have a 0, 1, 2, negative 1, negative 2. But on our y-axis, our numbers jump pretty fast. So we're going to maybe need to change and go by maybe 5s or 10s. This is represent 5, 10, 15, 20, etc. All right, so up here is about 75. All right, let's go ahead and graph those ordered pairs. So over 0, up 3. Over 1, up 15. Over 2, up 75. Negative 1, 3/5, and 3/25. So our graph looks like this. Notice it moves at a faster rate. We have these two numbers make a big difference in that first example. It's going to increase at a faster rate. Our domain and range are the same as the first example. The domain is all real numbers, and the range is everything above this line right here. So the range is y is greater than 0.